Okay, so taking a look at network infrastructure. First thing we're going to talk about is in iOS and just the basics about adding VLANs. Okay, don't assume that they exist when you're in your lab or even when you're doing your mock or practice labs. Okay, check them to make sure they exist or add them if they don't exist. Remember that just because two devices look like they're in the same VLAN, in other words, if I'm on a switch port, whether it's an Ethernet switch module on a router or whether it's in a Catalyst 3750 or 3560, really the same switch other than stacking. If I'm in a port and I see switch port voice VLAN 103 or switch port access VLAN 12, whatever I might see there, just because I see that does not mean that that VLAN actually exists. It should exist, and normally if you were to key that command in, if the VLAN did not exist, you would create the VLAN, or I should say the switch would automatically create it for you. However, if that command were in there or you keyed it in, I guess I shouldn't say if you keyed it in because then you would know whether it had been created or not because you'd see the syslog, assuming logging's turned on, the syslog output saying that the VLAN was created. But maybe you go into a lab and you see that the VLANs are already set. The access and voice VLANs are already set on the switch ports for servers, or mainly if it has a voice VLAN or auxiliary or .1Q, it's going to be a phone port. You see that they're already set up, so you assume those VLANs exist. But what if a proctor or pre-configuration had been entered? And of course, there is troubleshooting in the voice exam. I'll just go ahead and preempt there. There can be pre-configuration. I'll just go ahead and head off any conspiracy theory or any one that's concerned with proctors doing anything to change or modify or damage your configuration while you're in your lab, either while you're at your seat or even like go to lunch or a break. There is no time that they affect your configuration. However, before you ever sit down for your lab exam, they do have pre-configuration. Some of it is possibly very likely configured for you, some of it properly, some of it improperly, intentionally, as inherent troubleshooting. Okay, so maybe they already had the VLAN set for you, and it looks like switch port access VLAN 12, switch port voice VLAN 11. So you assume, well, my phones can talk to each other because they're both in switch port voice VLAN 11. And when I look at my phone's operational VLAN shows that they're in VLAN 11. Well, here's the problem. They could have created the VLANs, applied them to the interface, and then gone and deleted the VLANs. So you can't assume that a VLAN actually exists. And if the VLAN doesn't exist, two devices that appear to be in the same VLAN, but in fact are not because the VLAN is not actually there, will not be able to talk. Okay? They do have to have that logical entity in the VLAN database known as the particular VLAN ID. Okay, so in Catalyst iOS, we do a show VLAN or show VLAN brief. In Router iOS, if you type show VLANs, it will produce the VLANs that the router portion of the router knows about, not the Ethernet switch module. So you need show VLAN -switch. And then you can add them to either Catalyst iOS or Router from iOS, just standard config T mode. Okay, you don't have to name them. It can help. It's up to you, or up to what the lab says. By the way, throughout all of this lecture, throughout all of this class, if I say something is up to you, I really do mean that it's completely up to your discretion what you want to use, unless the wording in a particular exam is more specific. If it tells you what to do, then you have to do that thing. Okay, that always overrides any time that I'm going to say throughout all of this lecture. It overrides any time I might say your discretion. However, if the lab is not specific on something, and I tell you it's your discretion, then really it's up to you however you want to implement. Okay, you're not going to get any bonus points by doing anything additional or more or better. You just have to meet the prerequisites or the way that the task is worded. Meet the requirements of the task. That's all that's asked of you. There's no penalty for over-configuration, but there's no bonus points either. Okay, so looking at VLAN trunking protocol, obviously used for 802.1q trunks. Okay, so if we're looking in Catalyst iOS, we can either do switch port mode trunk, or we can, in the sense of, well, we'll actually look at phone ports in a minute. This is more for uplinks, so cat iOS over to a router, or looking at it from the router perspective. So if we're looking at an uplink, we're going to want to do switch port or hard code switch port mode trunk. Don't leave it to auto or switch port mode desirable. Okay? You might have to include which VLANs are allowed. So switch port, allowed VLANs, 101 through 105 or something like that. That's a form of security. If we see any .1q headers come through where the VLAN ID equals something other than the VLANs that are allowed, then we simply drop those frames. And that's on the Catalyst iOS side. Do keep in mind that could be one small portion of security, I suppose, that you could have, is the allowed VLANs. Okay, so router iOS, we define sub-interfaces if we're dealing with anything other than the native VLAN, and we can also define a sub-interface for the native VLAN. So what is the native VLAN? Well, with 802.1q, as opposed to ISL, which is Cisco proprietary inter-switch link trunking method, with the industry standard 802.1q, one second. Okay. With 802.1q, we have what's known as the native VLAN or the untagged VLAN. And the untagged VLAN, essentially, by default, is it essentially does not have an 802.1q header. It is just the Ethernet frame, like you would experience on any non-trunking switch port. So it doesn't have the 802.1q header. It doesn't have a VLAN ID subfield to that header. It doesn't have the 802.1p priority, user priority bits for class of service. It doesn't have any of those. And so this raw Ethernet header, standard Ethernet header, as you could look at it, can be passed on a router physical interface. So here the example would be interface fast Ethernet 0.0 with no sub-interface. That's one way. The other way is if we had a specifically noted sub-interface. So let's say interface fast Ethernet 00.10, and we would say encapsulation.1q VLAN ID 10, and then we would tag native on at the end. That would mean don't tag anything that we're using this sub-interface as a layer 3 interface. When we're passing this traffic back over to the switch, don't add the .1q header. Just leave it as a raw Ethernet frame. Those are the two ways that we can look at the native VLAN from a router mode. From a switch mode, we already see up there switch port mode trunk and switch port trunk encapsulation.1q. We can also say switch port trunk native VLAN and name that native VLAN. There is a way to tag all VLANs, including the native VLAN, and that is from the global config of Catalyst iOS, and then we would have to honor that from the router side. Okay, so here we see that in router iOS, we're simply not even mentioning the native VLAN, and we didn't mention it in Catalyst iOS, which means that it stays at the default, which is VLAN 1 as the default. Do make sure that they match on either side so that VTP traffic can pass properly. Okay, so we've got our VLAN ID for 11, and we've got our IP address or layer 3 information for that, and then we've got a data VLAN 12 also tagged with our layer 3 information for that. For phone ports, it's a good idea to use CDP to see what phones exist and where. Note that in the actual ccie voice exam, all testing centers, including San Jose, have layer 2 trunks or layer 2 VPNs, really, back to all of the hardware. So around the world, all of the hardware actually exists in San Jose. And the only thing that exists there local to you is your test candidate PC, not to be confused with the utility XP PC that you use in your rack. That's actually a virtual machine back in San Jose. All of your routers are back in San Jose, your CUCMs, your 3750 switch, your Ethernet switch module, or modules, all your Unity connection, all the servers, all of that is back in San Jose. And even in San Jose, it's in a different room, or at least logically in a different area. So the only thing local to you is your phones and an actual switch that is used to power your phones. But you are not telnetting in or consoling in to your switch there in front of you. You're consoling to the switch that logically looks at, or from your topology, logically looks like your corporate headquarter or your branch one or site, site one, site two, however they name them. Those 3750 and Ethernet switch modules. Okay, you will see phones show up. This is because they have everything layer 2 VPN'd. So, or layer 2 tunneling protocol, and if it's over the WAN, it's layer 2 tunneling protocol combined with L2TPv3, or layer 2 tunneling protocol version 3, so the WAN. What this means is that if you do a shutdown on one of your ports, you will not be actually powering down one of your phones. So you can shut a port and you'll notice that your phone doesn't react. If you want to actually power cycle a phone, you will need to physically disconnect the Ethernet from the phone in front of you and then power it back on. You also should be aware, and in fact, one of the ways you can look at that is if, let's say you're on your CAT 3750, and we'll do a demonstration of this in just a little bit. If you do a show power in line, you'll see, or actually if you do show CDP neighbor details, you'll see that the phone thinks that it's sending, or the switch thinks it's sending power to the phone, but then if you do show power in line, you'll see that there actually is no power that's being sent to the phone because it's remote. Okay, CDP makes it think that it is, but it's really not actually sending any layer 2 or layer 1 really power. Okay, with CDP, it's important to note that there's two versions, version 1 and version 2. And version 2 is the standard and the default, but it's possible that that the lab could change any parameters before you get in there, or any configuration. And version 1, amongst other things, doesn't carry any voice VLAN or auxiliary VLAN data. That's actually not mentioned in any of the documentation I've ever seen on CDP version 2. But the voice VLAN was one of the new features to version 2 way back, probably 2000, 2001. Okay, but do note that you need CDP version 2, you need CDP run globally, and you need CDP enable on each port. Again, those are all the defaults, but you might want to look for them. Okay, there are two methods that we can use to configure phone ports, and this applies to both the 4-port Ethernet switch module, which is what's in the lab, or the 3750, 3560. And these methods are either the trunk method, where we see up there that we're explicitly configuring the trunk, hard coding it to a mode trunk, or what's known as the access VLAN method. So the trunk port method, we explicitly configure the trunk. The access port method, we're saying switch port access VLAN 12, which is our data VLAN, and switch port voice VLAN 11. The switch port voice VLAN is, of course, what's being passed on to the phone through CDP to tell it what internal switch port it should attach to. Now, the thing with an access port is that it's not allowing trunking information, right? So if it's not allowing trunking information, then how are we distinguishing between two different VLANs? How are we actually sending data on two different VLANs? Well, the truth is that with the access port method, or actually anytime we enter the command switch port voice VLAN 11, or switch port voice VLAN whatever, other than the fact that other than the fact that that the voice VLAN information or ID is transmitted in CDP to the phone, if the other side doesn't happen to be a phone, CDP doesn't transfer that information, but the switchport voice VLAN still works for really anything on the other side. What it's essentially saying is that the pseudo trunking method. So it's still using .1q, and it's essentially allowing .1q headers on top of Ethernet headers or on top of Ethernet frames to come into the switch, but it's just checking their VLAN ID. And if the VLAN ID equals whatever the voice VLAN ID command is set to in the Catalyst switch, then it will automatically go ahead and allow that traffic to come in. If it's not the same as whatever the voice VLAN ID is configured to be, the VLAN ID is different on the actual incoming .1q header, then it will simply ignore that traffic. Okay, so it is a pseudo .1q trunk. It's just allowing one additional .1q header or one additional VLAN in addition to the native or untagged VLAN. If we're doing the trunk port method, where we hardcode switch port mode trunk, then what we need to do is we can still use the switch port voice VLAN command, but we also use the switch port trunk native command in order to send an access VLAN or the PC port VLAN on the back of the phone. Okay, looking at spanning tree, how this applies to the voice lab is basically in reducing the wait time for the phone to be able to talk or send traffic. Catalyst iOS, simply for the phone ports, spanning tree port fast. We noted back a couple slides back that for trunks, if we want, we can do spanning tree port fast trunk. And essentially what this is saying is don't wait for the blocking, learning, listening, forwarding mode. We're not dealing with rapid spanning tree or anything like that, but essentially sort of turn off spanning tree for this port or just don't listen for it. Okay, so that allows the phone to talk quicker. Looking at TFTP services, we need to enable TFTP first, of course, in serviceability for our Unified Communication Manager servers, or what I'll typically call CUCM from this point on. Anytime that you add files to the TFTP service, so we'll take a look at this, but in CUCM, when we go to the operating system dropdown, or the operating system, and we go to system upgrade and we add files to TFTP, we must restart the TFTP service. Also, those files are not kept in sync, rsync or anything else, not in CUCM 7, across servers. So if we want them to be available, or if we're told to make them available in a redundant fashion, maybe on the pub and the sub, or publisher and subscriber, then we need to add them to both and restart both TFTP services. In iOS, we can always do like a show flash pipe to include whatever phone load type or name or something like that if we want to see files that are specific to that. And then we can add those manually. So we can say TFTP-server in config mode, /:, the name of the path, and then the name of the file. And we can also use the alias command to make them look like they appear in the root directory, because when phones ask for firmware files, they don't ask for them through TFTP with any directory structure. On the contrary, when phones go to ask for desktop settings like ringtones or customization settings like the desktop picture or ringtones, they do ask for them, at least the desktop settings, in a specific directory structure. And we'll cover that in a little bit later and look at some examples of that. But we need to make sure that they appear aliased, just like you would through an FTP server or a web server, that the TFTP server hands them out, or at least recognizes and serves them up as if they appear from the root directory, even if they don't happen to be. So that's what the alias command is for. Looking at the network time protocol, we need to configure NTP on the publisher CUCM server, and all subscribers sync with the publisher. So any publishers in our system, if we were only told to do the CUCM server, you might only have to do that. It probably will not hurt nor take you very much time at all to make sure that all of your publisher servers, so like your Unity connection publisher, your UCCX, well actually UCCX in the lab is still Windows, so you can set that in Windows time. Again, I wouldn't be too concerned with it if the lab isn't more specific, but if they are, set it on all the servers that are necessary. Present server, for instance. And this can be configured via the CUOS, so the Cisco Unified Operating System command line, or you can do it through the web user interface. I think it's easier through the web interface. You can see if it's available. We'll take a look at it here in just a moment. The only way to fully verify the time is through the command line, although you can see if the service is accessible from the web interface. You should configure routers and switches, set their time zones first, and manually set the clock to within a second or two of whatever the server source is. If the server happens to be on the PSTN, then just look up at your local clock in the actual testing center since you don't have access to the PSTN WAN router in the lab. But if it happens to be one on your rack, like let's say you're told to sync to router 1, then make sure you set router 1 to whatever your local time is there at your testing center, and then set all of your other routers manually using the clock set command before you begin setting up NTP. This is to allow them to sync up a lot quicker. They'll still take a while to sync up, so once you enter your commands for NTP, don't sit there and wait for your routers to sync up to each other. Go on and do other things, trust that they will sync, and come back in maybe a half hour or an hour and check them out later. Okay, don't forget to set the proper date and time groups in CUCM. Also, there is a phone NTP reference in CUCM. This is for SIP phones if you should have them. Skinny phones get their time through the date time group and the Skinny protocol. SIP phones use NTP. So on iOS, you can set up a server as NTP master and then the stratum time. Any of you that have ever tried to install CUCM 8 or 8.5, you'll note that unless your router is set to stratum 2, or I always set it to stratum 2, but stratum 2 or 3, you will not be able to get your CUCM server to install. This is because the CUCM wants to be sure that it's looking at an NTP server with a stratum of no less than 4, no greater than 4, or worse off. Higher number, the worse, the lower number, the better, closer to the cesium atomic time clock. So keep in mind about stratum. Lower stratums outweigh a higher stratum, so if I'm not only doing NTP master, but I also have NTP server set, that is, I want to learn my time as a router from another router, but then I also want to be a master in the sense that I'll serve time to other people. Maybe I'm kind of a border router for my enterprise. Maybe router 1 is syncing from the PSTN, so I'm doing NTP server with the IP address of the PSTN, maybe a loopback, and then I'm also doing NTP master. I need to make sure that my stratum for NTP master on my router 1, let's say, is higher than what the PSTN server is sending. I can just configure the NTP server command, point it to the PSTN, and wait for a little while and do a show NTP status, or really show NTP associations is the one I like, to see what stratum the PSTN is telling me it's set at, and then I set mine at least 1 higher. Okay, that way I'll sync with the PSTN, but I'll also be able to serve time. If I set it equal to or lower, then I'll sync with myself first, and I won't really sync with the PSTN. Okay, it's always a good idea to do NTP source loopback. It's pretty much a good idea to always link everything, all sources of protocol traffic from your router, link them to a loopback, unless you're told otherwise. If you're told otherwise, obviously do whatever you're told. Okay, looking at DHCP inside CUCM, it's important and critical to enable the DHCP monitor service under serviceability, service activation, make sure it's running. and then configure your DHCP server. If you were told to use CUCM as a DHCP server, use whichever one they told you. If they didn't tell you, I'd probably use the publisher, not in a real environment. I'd probably never use CUCM DHCP, real environment, but this is for the lab. And then you would configure a subnet for each site. After you had configured the server, make sure you would assign the default router IP address and TFTP address and DNS if they asked you, but that's probably less likely that you DNS in the lab, although they certainly could ask you to do that. We'll look over that during this week. Ensure that IP helper address command is configured under any voice VLAN sub-interfaces on any routers or switches. So first of all, if I'm on a switch and I want to obtain DHCP information from that switch, I should note that I have to have an SVI, a switch virtual interface. Okay? I have to have a layer 3 component to my switch if the actual DHCP pool is on an iOS switch, or else I don't have any way of ever listening to layer 3 information, much less serving it back. It has to, of course, be for the subnet where the request, the DHCP request, is coming from. If I have a DHCP, and I'm going to pull up a topology here in a moment, but let's just say a headquarter switch, there's a phone attached to it, and I've got a headquarter router, which has a .1q layer 3 interface on that router. I don't have to use IP helper address if the DHCP pool is on the router. But if it's on the CUCM server, and the reason I don't have to if it's on the router is because I have a layer 3 interface where the router can listen for that request. And the router is serving it from a global pool, just looking to see what subnet it came from. Okay, but if I have that DHCP pool set on a CUCM server, and my phones are in a different VLAN from the server, as they most likely will be, or certainly most likely are in real installations, then I do need to have a helper address on my phone's VLAN, or VLAN subinterface, layer 3 interface, where I take that broadcast address. Can't be a unicast, because a unicast packet has both source and destination IP address. I can't have a source IP address if I'm a phone that doesn't have an IP address yet, right? I'm looking to get one. That's what DHCP is for. So my source is essentially blank. I've got a broadcast packet, and I need to turn that broadcast into a unicast. That's the router's job with the IP helper address. Turn that broadcast for bootp, bootps, a number of other things, DNS. There's a number of other IP forward protocol that can be done. But turn that broadcast DHCP into a unicast and send it on to the server, the actual unicast IP address of the CUCM server, let's say the publisher. So I need the IP helper address on any layer 3 interface where my phones are living and sending out their broadcasts. Then verify the address allocation under each scope. This is certainly possible in iOS. It's not really so possible in CUCM. Okay, there's really not even a command line to show you that. It's not the best DHCP server. And then ping the phone address to make sure you've allocated the gateway correctly. Go to the web interface for the phone. So just put the IP address in a web browser, the IP address of the phone. Make sure you can reach that web server. Okay, looking at iOS DHCP, we can verify address reservations with show IP DHCP bindings. You can check for maybe stale addresses with show CDP neighbor. Sometimes clearing a CDP table can help as well. So from exec mode but not config T mode, do a clear CDP table, and then power cycle any phones that take too much time to obtain an IP address. We'll go over this. We'll go over the actual configuration for this in just a bit in our demo. So looking at multicast routing is about the last thing that we need to look at before our demos with network infrastructure. Now multicast, of course, fits into media resources under music on hold, because that's, at least in what we're concerned with for the ccie voice lab, that's really the only time we care about multicast traffic. We might care about it for broadcast IPTV, but and in a number of other things in real networks. But for the lab, music on hold is about the only thing we care about multicast. But it really falls and it breaks down into two different components. One is the server configuration. The other is the network infrastructure. So we'll cover the infrastructure portion here. First of all, in a lab environment, a small lab environment like our ccie voice exam and practice labs, it's perfectly safe in a small lab environment to use PIM dense mode. And dense mode simply floods all multicast groups and multicast traffic everywhere. Okay, this is for routers. PIM is protocol independent multicast. We're not going to go into a long, lengthy discussion of multicast. There is easily an entire day worth of multicast that we could go over, maybe two. In fact, if you're interested in that and you happen to have the All Access Pass, please watch. I can send you a link to Brian McGahan's full day of IP multicast that he just recorded last week for his routing and switching class on demand. But we really don't need to go into a lot of detail for multicast as it pertains to the ccie voice lab, I should say. We'll use dense mode on the routers to flood it everywhere, and we can use a form of dense mode on the switches if we like as well. Now, there's already something called IGMP, or Internet Group Management Protocol, running on the 3750 switches and even on the Ethernet switch module portion router, where we have that ESW. And it snoops and listens for join requests. So by default, we have IGMP snooping turned on for VLAN. We can say no IGMP snooping in the CAT 3750 or even the Ethernet switch modules to turn it off. It's perfectly fine to leave it on both, but it can be helpful. There used to be a bug many iOS versions ago where we had to turn it off for the Ethernet switch module. That's not the case anymore. We just need to make sure that we have CCM Manager music on hold configured on any iOS router, and we'll talk about that when we get to media resources. But for the multicast portion, we can do no IGMP snooping on either the Ethernet switch module in the router iOS, or the Catalyst iOS, if we wish to turn it off just to avoid any possible troubleshooting. Okay, we can also just under any layer 3 interface that's either a incoming or an outgoing. So coming from the server, and we'll look at a topology and draw this up on the whiteboard in a moment, probably more so when we get to the media resources section. We would need it first incoming from the server VLAN, because the publisher and subscriber, at least one of the two, is where our music on hold server is going to lie. So we need PIM dense mode there on the incoming server VLAN layer 3 interface, most likely a layer 3 sub interface of a fast Ethernet at our corporate headquarter or site 1 site. We'll also need it outgoing to the voice VLAN layer 3 interface on the corporate headquarter or router 1. We'll also need it on the serial 1 or 2 serial subinterfaces as they point to the branch 1 and branch 2 routers, respectively, depending on where we need multicast traffic to go. Okay, so the PIM dense mode, it's safe to go ahead and put it on every interface. Again, in a lab environment, you never heard Mark telling you that it's safe to use PIM dense mode everywhere. Okay, in real production environment, you would never want to do that. In fact, you really wouldn't even want to do PIM sparse dash dense mode, because getting into a quick technical aside on that, it uses sparse mode if there is a rendezvous point to manage group membership, and if there's not, it falls back to dense mode, and so you just have the same huge bursting of information, flooding of information is the word I was looking for, out to all the interfaces and out across your WAN and wherever else, and you can get into a really high bandwidth or oversubscription or problem if it's not managed properly with QoS. Okay, but even if it is, you really don't want to leave multicast to dense or sparse dash dense. You really want to keep it on sparse mode only. That's in the real environment. In the lab, we're going to use dense mode. And then on, let's say your branch 1, you'd want it on your serial interface coming in from the corporate headquarters site, and then you'd also want it on your voice VLAN. So either a fast Ethernet subinterface out to a switch, or if it's an Ethernet switch module, then it would be the SVI, the voice VLAN switched virtual interface. You do not ever need it on your loopbacks to get out to the PSTN. That was an old configuration. Now all you need is CCM Manager. It can't hurt to put it on your loopbacks. That's perfectly fine if you want to do that.